Hello everyone, I'm Xiao Gang. Okay, in this lesson we'll talk about property replication. First, let's go back here. We still need an actor to make it easier for us to test. Okay, so what is property replication? It essentially means that some properties can be synchronized from the server to the client, such as health points, mana points, and the like, for our convenience. It's basically equivalent to not wanting to write RPCs for some things, because when you write an RPC, you generally call an RPC once. We don't call it free. So for this kind of property replication, it's equivalent to something that needs to be called frequently and periodically. Therefore, we generally use this kind of property replication. So in Blueprint, how do we do this property replication? First of all, here, we give it a default value. And for this default value, we give it a health. We give a health. After giving a health, for example, we give it 100. Okay. Good. Here we have a float value. Let's close it. Then let's close it first. We'll ignore this for now. Then here, we give it a tick. We give a tick. Then we only print on the client. We don't need to print on the server. So here we can give it's local control. We only control it locally. We only print the equivalent of only print our own health value. We do not print the health value of other players. Otherwise, there would be too much information. Then we just print it. Okay, and then here, we are here. Set this time to 0. Okay, good. Now let's start it. You will find that our top left corner should be printing continuously. Let's check why it's not printing. If it's not printing, let's see if we've made the correct changes here. It should be this one. Okay. This might not have been changed properly here. Oh, I made a mistake here. Wait, let me remove it. We should create a new map. The change here is wrong. Okay, I've created a new map here. You can see we are printing something here, right? We are printing health points here. So we put the health points here. Normally, we would need to write UMG and such here. We'll show you in the actual case later. If we write too many things here, it might not be easy for everyone to understand. Okay, then you can see that our player's health value is 100. So here we will create something like a flat reduce health, right? Then from the previous lesson, you can think that when a collision occurs, we execute attribute modify on the server and then broadcast that the attribute has been modified. So doing it this way is possible. But is there a more convenient way? Directly through property synchronization. But sometimes we directly prepare an actor. Okay, we give it a BP. Let me change this name. BP fireboard. Okay, then this fireboard. We are here. We give it a cube here. We turn off the collision of this cube. After turning off the cube's collision, we are here and we go to this place to make the cross-section a bit smaller. Okay, let's make it even smaller, change it to 0.1. Then we give it a box. Okay, let's pull this box up and scale it a bit. Once we have this box, we need to write the collision. Yeah, for this collision, let's just use begin overlap. Okay, so first, let's cast this actor. Actually, this part could be optimized, but we're not talking about optimization now. So let's ignore it for now. For this part, we should use this, not the game mode. BP 9 character 226. Then there is a property here. There is a property. We call it. Think about what this property should be called. Health. Set health. Of course, this must be on the server. So here, we'll use this. Use server. Use delete server. We only set it on the delete server. Okay. This part is, if you use this, you might have issues when clicking. So I need to avoid problems in this part. Actually, you can use a server. Yeah. The difference between the two is you can see here. Take a look at their underlying structure. Then you'll know the difference is this. As long as it's not a client, it is considered usable. And dedicated server must be a dedicated server because, besides the client, we also have standalone and other cases. Then we change it here. We change it to we first get, then we let it decrement, 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 and after that, we take this value. Then we just take this value, just decrement it. Okay. Then now we place this thing in the scene. Place one right in front of us. Okay, now let's execute. Let's execute it in standalone mode first. We execute it in standalone mode. You can see, right? Standalone mode works perfectly fine. No problem at all. Then if we switch to executing it on the server, let's take a look. You can see, but actually on the server, it is being deducted. We can change this to a listen server. You can see it is actually working normally too. But this is clearly wrong. This is obviously because you only changed the server's value. Your client's value has not been changed. So what is the correct approach? You should change this value to this. Replication is here. We can just select simple replication. Then after we select replication, this value will be synced from the server to the client. So here we can just use clandestine. Okay. Right. You can see it can also fully perceive. Right. So here, for convenience, let's just print everything. We won't make it check for local control anymore. This way, it's easier for everyone to see. Okay, you can see, right? This is the effect we want to achieve. And this is equivalent to you modifying the server's value. Then the server's value automatically receives perception, then synchronized to the client side. Actually, sometimes we will be here. We are in Repractic. We will set some synchronization rules for it. As for these specific synchronization rules, I will briefly go over them for everyone. Actually, these synchronization rules are right here. They basically correspond to each other. Take a look. For example, initial synchronization, or synchronize only to the owner, or skip the owner. Then here, when you're optimizing bandwidth, you can take a look. Some specific attributes you might only need on a specific link to actually synchronize. That's roughly what it means. Then we'll talk about C++ later. In fact, we often give it a replay method. When our attribute receives synchronization, we need to give it a method. This method is automatically generated for you. Then we can, at this point, print it out like this. That is received. Receive the synchronization of the health value modification. Okay, then we can take a look at this method. How is it called? You can see this place. The client extends to the head beside it, and we usually at this time, after we finish synchronizing, we can see we can at this place simply print it out. Print it again. Okay, when printing here, we'd better concatenate. Here, we put it here. If we piece it together, we'd better ARPA for UEC. Okay, then here, we give it this received health value. This should be the modified one. Modified. We usually go here to change this value. Let's print it now. Let me show you. Hey, you can see, right? Actually here, it differs from C++. In some aspects of behavior, it also mentions here, because of this, that is to say, you must separate blueprint and C++ writing styles, keep them distinct. When writing in C++, you need to test it separately, because their working methods are quite different. And here, it states that if you are shadow, use a function that accepts properties in blueprint red, it might not drop this reply notification. Even if they modify this value. Anyway, we just drop this set node to change it. Basically, what I want to say is, actually, there are some other things here. Actually, it's more at the C++ level. Actually, that's all for property synchronization. But there is a pitfall with property synchronization. That is, it's possible that your value is, for example, 1, 12, 3, 3, 4, 5, 6, 7, 8, 9, 1, then you change it very quickly, but the final result he receives must be 10. But the middle value is 23, 5, 786, or 789. He might not receive them, so when you synchronize properties, we generally use this kind of property synchronization only for less important properties. There is a small pitfall here, that is, if you wanted to synchronize in the order of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as expected, it might not meet your expectation because its update frequency and the bandwidths are affected by this aspect in a simple way, and then do not do it on the client side. I will modify this value because, for example, on the client side, modify this value. Here I am, because this place is definitely, this place should be the client side. Here I am. Echo to something bad. That is, I use this value. I force it to lock it to 99. Right. I force it to lock to 99. Then on the surface, it looks like 99. You see, for example, if we modify it like this once, this place, you see, it reports an error, right? So, under normal circumstances, you should not modify these values on the client side because doing so will cause some problems